Hey Team 6-1, we are going to be working on the metric system, and the metric system is a different system that what we traditionally use. We traditionally use English Standard, and so it's something that's fairly new to us, and here is just some background knowledge for you. If you haven't already, you need to go to the back and get a metric packet. It's in the bottom right-hand corner of the mailbox. Okay? Feel free to pause this video anytime that you need to. Our objective is that by the end of the week you should be able to use the metric system to measure length, distance, volume, mass, and maybe temperature. And then we also want to be able to convert within the metric system, like from centimeters to meters, or from metric system like meters to English Standard, and that would be like to miles or inches or yards and feet. Okay, so we'll work on those later. Again, feel free to pause anytime you need to. Alright, here we go. SI measurements. SI measurements is also known as the metric system. SI, known as the metric system. So on your paper you're going to write metric system, what's in pink there or red. And SI stands for System International, or International System of Measurement. Okay. So why do we have this system? It was developed to create a universal system of measurement, and it was going to be a common language for scientists. As of the year 2005, only 3 countries have not changed over to the metric system, and they are the United States, and Myanmar, and Liberia. As you can see from this graph, it shows that France was the first country to start the metric system, and it goes all the way back to down at the bottom 1996 or 98. It's kind of hard to see. I guess it's 98. Jamaica actually started using the metric system. Jimmy Carter, he was a president. He tried to get the metric system to be used after that big explosion in NASA from that video that you should have already watched. But people said no. Alright, so what is the metric system? Again, it's a common language for scientists, and it's based on units of 10. It uses decimals, and I know you've worked on decimals in math. And prefixes, those are little words added to the beginning of base words to each unit to measure how much of a unit. Okay, so there are 3 basic units to remember, or excuse me, 4 basic units to remember, and then 3 of them we add prefixes to change the size of whatever it is we are using. Okay, and the first one is a meter, and then a liter. We have grams, and then Celsius. And Celsius is the one we don't add prefixes to. Alright, on your paper, meter. Meter is the basic unit for length or distance, and its abbreviation is a small letter M, and we use rulers, meter sticks, or measuring tape, like construction workers would use that. For the liter, it's measuring liquid, and it's the base unit for volume, or how much space something takes up, so thinking about pouring liquid in a glass. And this abbreviation is a capital L. It's very, very important. I know it sounds kind of crazy, but it's really important because you're going to be communicating to me through some abbreviations. And we use a graduated cylinder or beaker, something that we can use to measure liquid, and you'll see pictures of those a little bit later. Okay, we use a formula or water displacement if we have solids that we can't actually use a formula for. Okay? And again, we'll be talking about these in class. Okay? So here's a picture of a graduated cylinder and of a beaker. Okay? So graduated cylinder, what we will do is we will use the curved liquid. Okay, so as you're zooming in, there on the right, you can see the eyeball, and you need to see where the liquid has curved, and the bottom part of it, that's where you measure. And this curved surface of the liquid is called a meniscus. We also use formulas for measuring solids and we can use a ruler, and then to find volume we take length times width times the height. But then for irregular solids, like maybe a rock or something like that, you really can't measure the size, we use water displacement. Okay, so how much did the water rise? And it looks like it measured, it went up 2, and so then we would say 2 liters. Okay. Next, we have an example of a regular solid. So if it's 4 centimeters by 3 centimeters by 7 centimeters, what we would do is take length times width times height. So 4 centimeters times 3 centimeters times 7 centimeters, and we would get 84. And because we are finding like a 3D shape, it is centimeters cubed. That exponent of a 3 is used. So that's really, really, really important. Here's an example of the volume of an irregular solid. Say, for example, a ring. Okay, in the before picture it is 64 milliliters, but in the after picture it is 68 milliliters. And again, see how I'm reading the bottom of the curve. And so this would be 4 milliliters. Okay. Grams, down at the very bottom, is the base unit for mass, and it's how much matter is in an object. For example, like, is it solid inside, or is it hollow, or doesn't have anything inside it? Okay? And the abbreviation for grams is a small case g, and we measure using a triple beam balance or a scale. Now, we have triple beam balances here at school, so we're going to be doing an activity so that we can learn how to use that and measure mass of things. It is not weight. Mass and weight are 2 separate things. So just because you see a scale there does not mean that we are measuring weight. We're measuring like how much matter is in that object. Okay. Celsius is the base unit for temperature, and we use the degree sign with a capital C, and we measure obviously still with a thermometer. Okay, so for some temperatures, water freezes at 0 degrees Celsius, and it boils at 100 degrees Celsius, and it's a lot different in the English Standard. Some prefixes that you will need to know are kilos. Kilos means 1,000, so the number value would be 1,000. Hecto means 100. We don't typically use that one, but go ahead and fill it in your paper anyway. Deca with a K is tens. Okay, and then we would be at our base unit. So between the deca and the deci, D-E-C-I, we would have our base units, and then we get really, really small. So deci is 1/10, as you see the decimal there. Centi is 1/100th, TH, you should know that from your decimal unit, and then milli is 1,000th, which again is decimal. Okay. Some easy way to remember all of those prefixes is the phrase kids have dreams, but dreams cost money. Okay, where the kids stands for kilo and the H is the hecto and the first D is dreams, and then that B stands for base unit. And again, that's where that would be like 1 meter or 1 liter or 1 gram, and then we add these prefixes to those words to show how it's bigger or smaller. And then dreams is deci, cost is centi, and money milli. Okay. You need to draw these charts on your paper. Okay, so you have some common units of length in the metric system, so you need to draw that chart. And you need to fill in that the kilometer is km, and again, it's a small k and a small m. Again, we don't use the hecto or the deca, so please leave those blank. You need to be copying these charts or tables just as they are. Just because we don't use the hecto doesn't mean you just leave it blank and don't even put it on there. Okay? You leave the right side of that table blank, but you need to fill in the left side. Okay? The meter is a small m. We don't really use decimeter, but we use centimeters, cm, and millimeters, mm. The middle one is the mass, where we'll use the kilogram and a gram and a milligram. So you just write those three. Again, draw these tables just as they are and fill them in. And then with the volume, we use liters, a capital L, and milliliters, which is a small m and a capital L. The scientific tools that we have are, again, match up the picture with the words. So we have a graduated cylinder, and then we have a beaker, and this is showing the meniscus. So I want you to write meniscus. We have test tubes and beaker. Okay, meniscus, again, the curved surface of the liquid, and we measure at the bottom. We also have flasks. Those are curved in. They will also help us measure water, or at least pour water. And we have a scale, or an electronic scale. And then we have the triple beam balance. Okay, and I know there's probably not a lot of room on your paper, so it doesn't have to be exactly on the line. Okay. And you are done with this video. So now you have a background knowledge of the metric system and 4 different units of measure that we will be using. Okay. And as always, don't forget, go Hawks!